Hi, in this video we'll show you what to do when you deploy your smart contracts using the transparent proxy pattern, but your implementation contains critical bugs that ruin your system. And first we'll pause the smart contract so that nobody can exploit the bug. Then we'll create a fix, we'll deploy it, we'll upgrade it, but using Defender and multisig, and it will make it much safer because you'll need a specified amount of accounts of people to approve the upgrade before it goes through. And there are a few videos like that on YouTube, but we decided to make a video with the full flow of the bug fixing and just what to do in this situation, not only simple upgrades with new features.
Exactly. So let's take a look on our contract we've left since the last video. Here is the beta version 2. We are going to the upgrade for that, but we've left the function mint with the address specified to of our choice. But you can see that the mint will be minting to the address of the contract. Address this, in other words. So it's the bug, and we want to fix that. So let's start with pausing the contract. We can do this by going to the Rinky address scan, and we can get our proxy address. So let's paste that and search. Let's go to the contract tab, and let's write the contract as the proxy. Because it's already verified, as you could see in the last video, so we want to find the function pause to connect to the Web3 with the contract, and we want to pause that. After that, when the transaction will be confirmed, we can check if it's paused in the read as proxy. The function paused, right? And it returns for now false. Let's refresh because the transaction didn't went through yet. Now it's true. Okay, so the contract is paused and we can continue our process.
Yeah, so it means that you can't transfer any tokens, so the users won't exploit the contract. So now going back to Visual Studio Code to see our bug fix, which is basically a copy of the v2 version named v3 with the same function, but as you can see we don't override the v2 contract, we override the base because we don't need the faulty code. And just a hint, you could try to override the mint function from the v2, but it would have to be virtual, otherwise compilator wouldn't let you do. So we have the bug fix. Now we want to deploy it, and previously when we wanted to upgrade our contract, we would use the upgrade proxy function, but you can't do this now because we want to use Defender for the upgrade itself. So in the v3 deployment script, we'll deploy only implementation as it is. So we deploy a breeder with v3 and verify it using vidoes, just like in previous video. So let's run this code. Let's deploy the third implementation. It's scripts, transparent, and specify the network. It's gonna be Rinky. And as you can see, since our last video, we added a contract sizer plugin, and we set up the optimization in hard.config to fix problems where contracts were too big to be deployed. and you can check this on our GitHub repository, just like all of the other files. So the implementation was deployed, and yeah, we could check this on either scan here, make sure it's verified, because the function sometimes fails, and if it fails, as usual, you just go and use npx hardhat verify with the address and network rinkiby, and then it will verify it for you if the verify function failed. And if you have other problems, just go for npx hardhat clean and then try verify again. But our case was successful, so now we can go to Defender to import the contract.
Okay, so let's go to the Defender, as Jacob said. We have to click Add Contract and import our contract. We'll set the name as, for example, Orange or Britter or whatever. Britter proxy, network rinkiby, and address of our proxy. We have to wait because it's analyzing. If it's verified, it will show ABI. Okay, great, it's verified, so we can add that. And we want to show you guys that you can upgrade the contract by openzeppelin Defender directly. So let's wait, because it's checking up. Okay, we can upgrade. And we have to paste the implementation address. Proxy, upgrader, yeah, 23, no description, no needed, by EOA, and let's try to upgrade. As we can see, we can approve and execute everything. And it lets us through. So it's not recommended way. Jacob, could you tell more about that?
Yeah, so the current state is having only ownership of only one MetaMask account. We could upgrade implementations of the smart contract, and we don't want to look like that. It's much better to have a few required approval from, let's say, 2 people until the contract is upgraded. And to do that, we need to create a new multisig wallet.
Yeah, right. That's our next step. So to do that, we go to admin section, we add contract and create gnosis safe. We'll just set the name, might be the Britter proxy safe. Yeah, why not rinkiby? And we'll be choosing the owners of the gnosis safe. So let's add 3 MetaMask accounts and set the threshold for 2, because we want at least 2 accounts for the approval to let the transaction through. Let's create gnosis safe. It's simple as that.
So the gnosis safe is ready, but it isn't linked to anything. And what we want to do here is to make the gnosis safe an admin of our proxy. So if we go to our proxy contract, you can see that when you go to write contract, we have an admin interface, so not the normal user interface, but functions for upgrading and changing admin stuff. And we could try to use them to change the current admin. And our new admin would be the gnosis safe. So we need to copy the address. And yeah, if we paste the address and we are the account that deployed the proxy, we won't be able to change it because we are actually not the admin of this proxy. The admin of this proxy is another contract, which you can find when we go to the deploy proxy function and go to the module in upgrade core responsible for it. So it's deploy proxy TS. You can see in the proxy deployment section that when you deploy a transparent proxy, you always create a proxy admin contract from the factory, and it's basically a proxy admin sol contract. And to find this one, you would have to go to your .openzeppelin directory, and the network you use now, it's WinKB, and copy this address, which is the address of the proxy admin contract, which should be used for communication with the admin panel. And here you can see similar functions, which will indeed talk to the to our main proxy as an owner of it. So here we specify the proxy we use. So it's this one. And new admin, so our gnosis wallet. And this one will go through. And while it's processing, we can go back to our Defender proposals. It's confirmed. So when you go to the proposal where we wanted to upgrade the contract using only one account, you can see that it says that upgrade owner has changed because we changed it from my account to the gnosis safe address. So now to upgrade it using the multi-signature, we have to go to our contract and upgrade it again and do the same things. New implementation address, upgrade to v3 multisig, and now the system should automatically realize that we're using multisig, and yeah, indeed it wants us to approve it using at least 2 accounts. So we approve it using 1 account, then switch to another one, and now we can approve and execute because we will fulfill the approval threshold. And when it's ready, we can go back to our proxy. It's executed. And go to our contract again. And we should have an info about the current implementation. So if you go to it is a proxy, we see that we have a new implementation at this address. And it's the breather v3 with the bugfix.
Okay, great. So now let's check it out. Here we can see that the current implementation is not verified. And to do that, we can go and verify that. Going to Visual Studio Code. And as before, we'll just do npx password verify.
And specify the network. Yeah, but even if this one failed, you just have to type npx hardhat clean, because the already verified. Okay, so it was probably a lag from either scan.
Okay, so now we want to check if it's post, as we did on the beginning of the video, the proxy one. And it's true. So to try and verify if the mint functionality works, we need to unpause first. So let's go to the right proxy. Let's connect to our MetaMask and let's unpause.
I think that I'm on the wrong MetaMask account, so we need to switch to the deployer, to the one with the pausing rights here. Yeah, now we are able to unpause.
Okay, and now if the transaction will go through, we can try out if the mint function is working as it be.
Yeah, so we can mint some tokens, but we need the role first, minter role, because we haven't set it. So to get the role bytes, we go to read as proxy and get the bytes from here and grant the role. And when it goes through, we'll be able to mint some tokens to our other account. Let's say this one. And it's been 10 tokens, so this much way. Something went wrong here while copying. I think that we need to refresh the page because Etherscan bugged out. And so again, address and amount using our deployer. So And when it succeeds, we can go to our tracker, which redirects us to the token path. And as you can see, we initially minted 10,000 tokens, and now 10 more on top of that, but for another address. And our bug in the previous V2 version would make the minted tokens stay on the contract instead of sending the tokens to the recipient. But now, after a minute, you can see that we already have 10 more tokens, and you just need to wait a while to see a new address showing up here with 10 more tokens. Yeah, so as you can see, it's the address I selected in the minting function. So everything seems to be working already. And to sum it up, we paused the smart contract so that nobody can exploit the bug. We deployed a new version, but using Defender, using multisig, so much safer method. Then we unpaused the contract to make it work again. And we checked whether the bugfix worked, and looks like it works. So the mission is successful here, though it was only about transparent proxies, and we plan to publish videos about UPS proxies and beacon proxies with practical information in full flows like here. So if you're interested, subscribe to our channel, and see you next time.
Yeah, thank you. See you.